All right, we're looking at 73 today, and it is areas of triangles, trapezoids, and rhombi. Rhombi is plural for rhombus. You learn how to talk. All right, so warm up. We have here to find the area. Now, just real quick to remind you, if I wanted to find the perimeter of a parallelogram, I would just add up all of the sides, and this is 3.5, that's 3.5. That would be the perimeter, but I want the area. An area of a parallelogram is base times height. So the base here is 6. So that would be the area is 6 times, and what is the height? Well, the height is the actual perpendicular to the base, so the altitude, which is 3.1. So 6 times 3.1, that answer should be, I'd like to say 18.6, but I could be wrong. Anybody checking that? Anybody?
18.6.
All right, thank you. I mean, 6 times 3 and 6 times 0.1. And what would you label that? Meters squared, because it's area, okay? So I'm not using that slant height, that 3.6. All right, what is the formula for the area of a triangle? Well, that formula is 1/2 base times height, and you have those yellow formula sheets to be referencing. So 1/2 base times height. Oh, I totally put that in the line, guys. That doesn't belong in the line. And that would be, the base here is 11, and the height is 6.5. So I'm not using the sides of the triangle. So it is 1/2 of 6.5 times 11. All right, throw that in your calculators for me. I'm already screwed up this morning. All right, what do we get? This is where you need your calculators out. Everyone seems to know where their phones are. Does anybody agree with him? Would you say 35 point? Any? It doesn't tell us what's round to. So 34 point, you said 7? 35.7. Oh, I wrote it right. 0.75? Yes. For the 50th time. That was rough. Okay, I hope you guys agree with him. Next one is a trapezoid, and if you would flip it over, you could see here's your base, and here is your height. And a trapezoid is simply base times height. All right, so the base is 9, and the height is 4. I don't need a calculator for this. What is it?
36.
It is 36 what?
Yards.
Squared. All right. So when we're doing area, we're not using the slant height. Now, we could use a slant height to help us find the regular height, but we always are talking about that perpendicular. All right, so if you put that in that line, you can take a second and take that out.
I think you should have to pass a test to break up a fight. What page is this? Nowadays.
All right, so a trapezoid is a quadrilateral with exactly one pair of parallel sides. So here is your set of parallel sides on the top here. Here's your trapezoid. And so sometimes these sides are equal, sometimes one is up and down. So all you know is you have one set of parallel sides. On this, let's talk about this. This would be considered base 1 on the top. This would be considered base 2 on the bottom. Now, we normally just write that as B with a little 1 and B with a little 2, so subscripts there. These are called your legs. All right, so the bases are the 2 parallel sides. The 2 parallel sides. And the legs are the non-parallel sides. 2 non-parallel sides. And the height, as always, is the perpendicular line. So the height is really the altitude. It is distance between bases. Distance between bases. And I'm going to make you remember that it has to be perpendicular. Do you remember your perpendicular symbol? Upside down T. Do you remember that's perpendicular? Should I write out the word perpendicular?
Yeah.
So it is perpendicular to the base. Now I have two sets of parentheses. Perpendicular
Wait, so that C in the upside down
to base. No, that was a parenthesis. I'm going to get rid of this parenthesis now. So it looks like an upside down T, like a 90-degree angle. So that's your perpendicular symbol. So perpendicular to base.
I got rather right out perpendicular.
Really?
Yeah, I don't think I'm gonna.
Oh, well, it looks like 90-degree angles. Well, I am just too lazy to write out the word perpendicular, so it's all you. Whatever you want to do.
It hurts. Getting nauseous again.
Unfortunately, stuff is going around again. All right, now the area of a triangle with a base B and height is 1/2 base times height. So here's your base, here's your height, but you have to remember that it's 1/2. And why is it 1/2? Let me just grab an extra sheet of paper. Any triangle can be fit into a rectangle. Like if I draw a rectangle or a square, do you see that that could be a triangle? I split it in half. And so if you think about the area of a rectangle is base times height, well, the area of a triangle is half of that, because isn't it half of the rectangle? And I know we have this triangle that looks like this, but can you imagine fitting this in here, fitting it in a rectangle? If we would cut this triangle in pieces, this piece would go over here, or however, like these pieces would fill with the triangle, and this triangle is truly half of the rectangle. So that's why. Well, yeah, but do you see that this is the same here? We could flip this over and flip this over. So that is why an area of a triangle is half of a rectangle. Okay, now, I thought so, right? Now, this looks a little confusing, and I get it. There's two ways to write this formula. I prefer this way because I think it's just easier to see. That's my preference, but this is the same. So what are they doing here? You take the base 1 and base 2, the parallel sides, you add them together, multiply it by the height, and then you divide it by 2. And that seems a little crazy. So I like this formula. This half base 1 plus base 2, guys, you're taking the average base. So if you could drop this line and cut this little piece off and bring it over here, and then drop this line and cut this little piece off, the idea is we would create this rectangle, okay? If we cut this off, put it over here, and we would create this rectangle. Or maybe I cut this off and add it to here. And the idea is if you take the little piece and the big piece, add them together, and take half of it, isn't that taking the average? Take the big and the small and divide it by 2. So basically you're creating a rectangle out of here. And then you multiply it by the height. And I think I can do better with that because I didn't do a good job of cutting that off. Let me just show you. This could be a trapezoid. Do you see my trapezoid? There's parallel sides. That's all I need was the one set of parallel sides. This could be a right angle. We don't know. But if I could just cut this piece off and flip it up here. Do you see this piece here going here? Do you see that it creates a rectangle now? And the area of a rectangle is base times height. Now, with my trapezoid, what I did was I took B1 plus B2, base 1 plus base 2, and when you multiply by a half, it's the same as dividing it by 2. And if I do that, I'm taking the short and the long, I'm adding together and dividing it by 2. That's the same idea as taking that and putting it up there. So we're taking the average. So I'm not doubling it. I'm just saying what's between these two things. And then I take that and multiply that by the height. That's what you're doing. So I do like this formula better. Half the bases together times height. That's your average base times the height. Formula on here. Here's your parallelogram formula, your triangle formula. They have the H up front. Doesn't matter where it is, but it's the idea that you're taking half the two bases together. Area of a circle, circumference of a circle, and then we have rhombus and kite. So we'll come back to these things. But I want to make sure you have these formulas. So it says to summarize, here are the different ways to view a trapezoid. They have half the height times the two bases added together, which is half the height, and then add the two bases. Or they have it this way. But it's funny because up here they also have the H second. And then down here, you could do height times adding the two bases divided by 2. Multiplying by half is the same as dividing by 2. So it doesn't matter which base you label as 1 or 2 because we're adding them. Bless you. All right, so let's just start trying some. So find the area of each trapezoid. You have a formula sheet, but I'm going to transfer area on here, which is 1/2 base 1 plus base 2 times height. So I like this because I like to sort of get those bases in. Again, your formula sheet put the h out front, so it's up to you which one you want to use. I'm going to put this on there. Okay, so if we have the height, base 1 and base 2, you don't have to draw the trapezoid, but if you did, it might look something like this, where here's 12, here's 21, and if I drop a perpendicular, that's 8. That's what my trapezoid would look like, not drawn to scale. All right, so area, 1/2 base plus base times the height. That's it. So the 1/2 base times base, or base plus base, is really like the base times the height. All right, so throw all that in your calculator and tell me what you get. I mean, you don't have to use your calculator, but I probably would want to. Be quicker. Anybody? Yep, and what would we label it? Centimeters squared, yeah, because it is area. Okay, next one, same idea. You could draw the picture if you wanted to, but here are your two bases, and there's your height. So area is 1/2. Now, these bases are pretty big. 145 inches, 121 inches. We're really finding the average, what's between 145 and 121, and then multiply by the height of 42. You get a big number. See, all you have to do is you use the calculator that's out in front of you. What'd you get? Should be like 5,586.
5,586.
Yeah, and then we would label it
Inches squared.
inches squared. Okay, there is no extra information given on these. So I would consider this base 1, base 2, and then the 7 is the height. I do not need the slant height to find the area. If I was finding the perimeter, I would not use the 7. I would need the slant heights, which we don't have. So go ahead, find me the area. What are you confused on?
Why they would do it the way you should.
Why they would or wouldn't?
Like to cut off.
Oh, well, if you would cut this off, you could sort of attach it over here. You might have to attach a little here and a little there.
Yeah, but that doesn't make any sense. Why would you just cut off the access to these?
Well, if I
Number 7, like just draw this straight down from the end.
because then I'm missing some of that length.
Yeah, but now you're just adding the length.
Well, if I wanted to make this a rectangle, I'd have to cut off this little sliver, bring it over here, and cut off a little chunk here and put it in here.
Well, doesn't it change the numbers?
Well, what it would do is it would take, you know how 15 plus 17 is 32, divide it by 2. If I created this into a rectangle and I cut off the piece that I need and I put it up here, both of these would then be 16 and the height would be 7. So we could take a piece of paper for any parallelogram and we could cut off the pieces and sort of retape it together to make it a rectangle. And that's the idea. And that rectangle would be 16 by 7. So do me a favor, just do 1/2 of 15 plus 17. That's half of 32, right?
Yeah.
What you're really doing is taking 16 times 7. You're mathematically transforming this into a rectangle. That's why we take the average bases. So cut off the little sliver that goes to the side, cut off this triangle that goes to the side, and then we would sort of piece them together to make one big chunk right here. And since that's gone, that would give us our average of 16. We should get 112 inches squared.
It makes a lot more sense.
But that's what you're really doing. Every time you do this, it'd be like, this would be a rectangle here. So if I could just cut off this little tip, did you see if I could cut this off and then I could fill it in right here?
Yeah.
Then now do you see that I have a rectangle? But to find the height, or to find this base, I have to take 8 plus 12 and divide it by 2.
Oh, you gotta see him after the big fight.
All right.
At some point in your life, you're going to have to learn to keep them up.
So 8 plus 12, and then times 8. That's totally recorded. All right. So what do we get for the area? Again, if you take this, it's really half of 20. We're saying if we turn this into a rectangle like this, the sides would be 10 and the height would be 8. All right, do we get 80 centimeters squared? All right, so the next ones, we have some extra information. What do I not need to find the area of my trapezoid? So it's 1/2 the base 1 plus base 2 times the height. How do I know where the bases are? The bases are the parallel sides. The bases have that altitude. So here is base 1 or base 2, it doesn't matter to me. I normally just do top and bottom. And which one is the height? Has the one with the 90 degrees. So this I don't need right now. Do you see that? All right, so this was extra. So when we find our area, we do want to see what you're plugging in. 8.7 plus 2.9, the two bases, times a height of 6. So show us what you plug in, and what do we get out? No one's talking to me? All right, well, you better double check me.
34.8.
Yep, 34.8, and what will we label it?
That's kilometers, right?
Squared. KM is kilometers, you're right. Or kilometers, I guess it depends, you know, if you say creek or crick. Creek or crick, people. Creek all the way. Creek.
No, it's great.
Creek. Your mom probably says good riddance. See you later. Come back when the street lights turn on.
Get out of here.
All right, guys, what don't I need here? What do I need here? What are my bases?
The 5.7, you don't need that.
I don't need that?
Yeah.
Okay, I want to make sure. You don't, that's your slant height. So here's base 1, here's base 2, and here is the height. So you're amazing.
Oh, I know.
Don't let anyone tell you anything different. All right, what do we get, folks? Throw that in the calculator. I mean, you could do the longhand math. I'm just, you know.
Oh, I'm doing the real long hand math.
I don't believe it. Should be 21.6 inches squared. Yeah? All right. Oh, no. Now we have to think a little more. It's horrible. All right. They want us to find B2, which is the one base, if they gave us the area. Now, notice that the altitude is outside, and that's fine. I could draw that inside here, as long as it goes from base to base, and it's in a right angle. So we know our formula is area equals 1/2 base 1 plus base 2 times the height. Okay, so fill in what we know. We actually know the area is 231. We know base 1, and we know the height. So that would be 1/2. Base 1 is 23. We don't know base 2. Now, that little 2 has nothing. It's not a square. Okay, it's just saying first base, second base. It's not a square. And then times the height of 11. So do you see that I'm solving it? And if that little B2 throws you off, just write it as the base. We know which one it is. How do I deal with this? What would you guys do?
Divide by something.
Cross, like, multiply 23 and the base by 11.
Okay, so distribute.
Distribute.
Yeah, now here's the only thing. The way I have it with the 1/2 here and the base here, let's put that together and then distribute. So since these are on the outside, 1/2 times 11 would be 5.5, and then I'll distribute. So that's the only downfall with the way I've been writing it, is not having the 1/2 and that 11 together. But you see that I can multiply those two, and now I can distribute. So 231 equals, should be 126.5 plus, and then 5.5 times the base, or B2. So that's my only downfall. I like writing this way because I like to think about how I'm averaging the bases and multiplying by the height, base times height. But it does give me these two numbers on the outside. So I put those together. Okay. And now we need to solve. So what would I do first to get B2 by itself? Get rid of the 126.5 or the 5.5?
126.
Okay, so subtract that from both sides. All right. Check my math. I get 104.5 equals 5.5 B2. And then what?
Divide 5.5 by both sides.
Yeah, yep. Divide both sides by 5.5. Yep. So B2 equals, I think it works out to be a nice 19. What would my label be?
Millimeters.
What do you need, mister? Oh. It would just be millimeters. It's not millimeters squared. Do you see why? You just found the base. You didn't find the area. We were given the area. Okay, so same idea. This time the area is 8 feet. I have B1 again. I'm looking for B2, and that is the height. So let's fill in our formula. I think templating your formula is very helpful by just sort of rewriting it here. So if you're using that one, that's fine, or maybe half H. And so the area we know is 8. That's what's different, is we know the outcome. And we add the bases. So 3 plus base 2 times a height of 2. All right, so I'm going to clean up the half times 2, which is 1. Well, that doesn't change anything, right? A half of 2 is 1, and it's all multiplication here. So if we distribute the 1, we get 3 plus B2, and then what?
Subtract 3.
Yeah, what's B2 equal? Base 2. 5. And what will we label it? Yeah, 5 feet. Okay, so there are your trapezoids. Now, I know this is a bit longer, but we're going to try to knock this out. The next idea goes on to rhombus, and I feel like parallelograms, rectangle, square, we're good at. Trapezoids we forget about. They're a little bit different. And I feel like a rhombus is the shape that no one ever remembers anything about. I don't know why. We just exclude it from everything. Okay? A rhombus is like taking a square. All 4 sides are congruent. It's like taking a square and pushing it to the side. A parallelogram is like taking a rectangle and pushing it to the side. We lose those 90-degree angles, but there's a lot of properties there. So in all reality, a rhombus is a parallelogram. A rhombus is a parallelogram. The difference is a parallelogram with 4 congruent sides. That's the big difference. 4 congruent sides. So we have 4 congruent sides, and there's a lot of properties about a rhombus. I'm going to call this A, B, C, D. And we're going to get to that. So we have these diagonals. It breaks up. It makes these 4 little lines. But the reason I want to label it A, B, C, D is we're worried about the area. And the area is half diagonal 1 times diagonal 2. Okay, so if you look, that's why these diagonals there. AC is the same as saying diagonal 1. So this is like diagonal 1, and BD is diagonal 2. That's all you're doing. So let me see here. What I'm doing in blue, this would be your first diagonal, the whole thing. And then what I'm doing in pink, that'd be like your diagonal 2. Okay? So it's the idea that in one diagonal will always be longer than the other because it's been stretched. So that's how easy the area of a rhombus is, or a kite. Half diagonal 1 times diagonal 2. So the D's, make a little note here, the D's stand for the diagonals. Okay? So you remember what the D stands for. I don't need height, I don't need the side. Now there are other ways to find the area of a rhombus, but I will tell you this is probably the easier way. The problem is if you don't know the diagonals, you have to find them. So the first thing we have is we have rhombus WX YZ, which honestly, that is wrong. Please change, well, we can't really. Please change it to WXYZ. Flip this around. You have to go in order. So WXZY is how it should be named. You can't jump. So that is a problem. Now, one diagonal, so diagonal 1 is 10 meters. Diagonal 2 is 20 meters. It doesn't matter which one you call what because we're multiplying. And to find the area of a rhombus, it is 1/2 diagonal 1 times diagonal 2. So that's pretty simple. It's 1/2 of 10 times 20. So you can throw that in the calculator. You can take 10 times 20 and take half of it. No matter how you cut it, you get 100, and it would be meters squared. That's it. Pretty simple when you know the diagonals. All right, now look at number 13. It doesn't give us a picture, but it does tell us we have rhombus ABCD. So if you wanted a picture, you could sketch one. Since it's rhombus, all four sides are equal, but there's not right angles. And we go around, so you can't jump. A, B, C, D. You got to go clockwise or counterclockwise. The area is 240 meters squared. And diagonal 1 is 20 meters. Now, it doesn't tell us which diagonal is which. So we'll just say here's diagonal 1. That's 20 meters. And they want us to find diagonal 2. All right, well, if area equals 1/2 D1 times D2, I know the area is 240. I'm working backwards. That is half of diagonal 1 times diagonal 2. So we're doing some algebra here. 240 equals 1/2 of 20, which is 10. And then how do I get D2 by itself? So D2 is diagonal 2. It's not a square. Divide both sides by 10. And what do I get? 24. 24 what? Yep, just meters because you just found the length of it, okay? Remember, that little D2 is not D squared. So there's no square root. D2 is just saying find the second diagonal. It's the same as calling it Y. All right, so we have a couple more to do, and this is where we're going to run into a couple issues. So if you flip it over and you look at number 14, they don't give you the diagonals. What they give you is a piece. This piece right here is 9. And this piece right here is 5. Do you see how they give us those pieces? So there's a really important rule that we need to go back and draw in our rhombus. So I'm flipping it back. I know we just came over. On a rhombus, the diagonals, so make a note here, diagonals bisect each other. Diagonals, actually we're going to go further. Diagonals are perpendicular. I'll write out the word for you. Perpendicular bisectors. So perpendicular meaning they intersect each other at a 90-degree angle. Bisector, I'm trying to find another color here. Bisector meaning that they cross and make congruent pieces. So these two, I don't think you can see this, make 90-degree angles, and then this piece is congruent to this piece, and this piece is congruent to this piece. So bisector means they split into two pieces. So bisector means cut in half. That's what bisector means. Perpendicular means makes right angles. That's a lot of information, and I think that's why we forget some of this stuff. So the diagonals cut each other in half, and they make 90-degree angles. All right, so diagonals are perpendicular bisectors, meaning bisectors cut in half. Perpendicular makes right angles. All right, can I flip it back over? Okay, so if this is 9, guess what this is? 9. So diagonal 1 is 18 meters. If this piece is 5, this piece is also 5. So diagonal 2 is 10 meters. See how simple that was? So what's my area of a kite or a rhombus? 1/2 D1 times D2. So the area is 1/2 of 18 times 10, which is really, should be 90 meters squared. So it wasn't so bad, was it? All right, same idea. As long as I know this is a rhombus. That is the only thing I don't like about these problems. They pretty much, these are all rhombi is the plural. So rhombi, number 14 through 16 are all rhombi. So look at this. If this is 17, this is 17 feet. If this is 11, this is 11 feet. So the diagonal here is 22, and the diagonal here is 34. Everybody agree with my math there? So area is 1/2 diagonal 1 times diagonal 2. So what's my area? 374 feet squared. Okay, we have one last one, and it's a little bit tougher. And the reason this last one is a little tougher is I know that this is 11. I know that this is also 11. Got it? The problem is I don't know this. Now, can you please take a minute and think about this as a triangle? And didn't I tell you when the diagonals intersect, they bisect each other, so that's why these are equal. That means these are equal. But if this is 11, this was a right angle, wasn't it? Didn't I say they are perpendicular bisectors? So I can find this piece, I'll call this A, as in A squared plus 11 squared equals 15 squared. Do you see that blue right triangle? Okay. So we got A squared plus 121 equals, I think it's 225. So what does A squared equal? 220. Anyone helping me? You're all halfway out the door. Should be 104. Now I'm going to take the square root, and the square root of 104 is not an exact number. It is 10 point, let's make it 10.2. All right, so if this is 10.2, this is 10.2, so my other diagonal is 20.4 feet. All right, so we found that each piece is 10.2. That gives us a total diagonal of 20.4. The other diagonal, don't forget, I'll make this diagonal 1 and this diagonal 2, is 22. So we don't want to get wrapped up and think, oh, we finished this problem. All you did with Pythagorean theorem was find a missing side. But the key to being able to do that is know that you have a right triangle where the diagonals meet and that the diagonals bisect each other. So now we need to do our due diligence and find the area by taking half of diagonal 1, which is 20.4. I'm going to put it in parentheses, times diagonal 2. And we should end up with an area about 224.4, and it would be feet squared. Remember, we did round the value of that diagonal, so that does carry through.